Hi students and friends, this is your host and teacher Syed Ayaz with you. You're watching Learn and Teach by Sir Ayaz. So I will continue my video session for 5070 and I was doing variant 22 of May-June 2015. I am done till B6, so I will continue from B7. Titanium can be manufactured by heating titanium chloride TiCl4 with magnesium. A. Construct the equation for this reaction. So we have TiCl4, one of the reactant. Another reactant is magnesium. So I will write Mg here. So magnesium is more reactive than titanium. This equation suggests that magnesium is more reactive than titanium. So we'll get magnesium chloride and titanium. Formula for titanium must be Ti. What about magnesium? Formula between magnesium and chlorine. Look at the position of magnesium and chlorine. Where's magnesium? Magnesium is here. Valency is +2. What about chlorine? Chlorine is group 7, -1. So +2, -1. Ignore the charges. We'll get MgCl2. Let's balance the equation. There are 4 Cl on the left-hand side of the equation. So there must be 4 on right-hand side. So I'll write 2 here and 2 before magnesium on the left-hand side. This is balanced now. B. Explain why this reaction involves both oxidation and reduction. If you look at the equation, you can explain in terms of loss and gain of electron or change in oxidation number. Explanation. Loss or gain of electrons, change in oxidation number. So for magnesium, it has reacted with chlorine. It means it has lost electrons. From here till here, it has lost electron. So we write oxidation because Mg loses electrons. Or you can explain this in terms of change in oxidation number. The oxidation number on element must be 0. Here it must be carrying 0. And on the right hand side, it must be +2. It's a metal, it's +2. Or increase in oxidation number from 0 to +2. What about Ti, titanium? It's reduced. So you write reduction because Ti ions gain electron. Or there must be decrease in oxidation number. You can mention the oxidation number for Ti. On the left hand side, it must be +4 on Ti. And on the right hand side, it is 0. So it's decrease in oxidation number. from +4 to 0. That's why it's reduction. Next question, what mass of titanium can be made from 125 gram of titanium 4 chloride? So I will write the equation here for your convenience. So it will become easier for us to calculate. We have TiCl4 plus 2 Mg gives Ti plus 2 Mg Cl2. As we are concerned, the mass of titanium, and it's made from titanium 4 chloride, so I will erase other reactant and product. So we have Ti and TiCl4 and Ti. What about the MR of TiCl4? MR of TiCl4 is Ti. Here is Ti. 48 is the AR of 40I. What about chlorine? It's 35.5. So 48 plus 4 multiplied by 35.5. 35.5 multiplied by 4 plus 48, 190. 190 is the MR of TiCl4. So you will consider 190 mg. 190 grams gives AR of Ti is 48, so you write 48 grams. Therefore, 125 gram gives X gram of Ti. With the cross, we'll get 190x is equal to 48 multiplied by 125. Or x is equal to 48 multiplied by 125 divided by 190. 48 into 125 divided by 190. 31.578. 31.578. You can even round it off to 31.6. This will be the final answer. D. Which metal is the least reactive, magnesium or titanium? Explain your answer. It's very easy, titanium. Because magnesium can displace titanium. Magnesium can displace titanium from its compound. E. Titanium 4 chloride is a liquid with a low boiling point of 126 degrees centigrade. Suggest the structure and bonding of titanium 4 chloride. So it must be a simple molecule. Because of this low boiling point, and bonding is covalent. F. Explain how titanium metal conducts electricity. It's due to the presence of free electrons. You can write contain mobile or delocalized electrons. B8. The flow chart shows the steps involved in the manufacture of polypropylene nitride. We have crude oil, making propene, and from propene, we have propene nitrile, then we have polypropene propene nitrile. A long chain alkanes such as C17H36 can be cracked to form propene C3H6. Construct an equation to show the cracking of C17H6 to form propene. So the reactant is C17H36, and they have mentioned one of the product that is that is propene, the formula for propene. Recall the general formula for alkenes. Propene is an alkene. It's CnH2n. So propene must be having 3 carbon atoms. So it's here C3H6. What about the other product? When you crack long chain alkanes, you will get either alkane and alkene or alkene and hydrogen gas. In this case, we will definitely be getting alkane. So subtract the number of carbon atoms from the 17. What you will get? Get C14. So alkane must be of C14. So what is the general formula for alkane? It's CnH2n plus 2. C14. 2 multiplied by 14 is 28. 28 plus 2 is 30. So you write C14H30 here. B, the equation shows the reaction to make propene nitride. This is the equation. 2C3H6G plus 2NH3G plus CO2G gives 2C3H3NG plus 6H2OG. Describe and explain what happens to the rate of this reaction if the temperature is increased. Now, if you increase the temperature, the rate increases. So first of all, you can write rate increases or reaction is faster. Rate increases. What reasons you can write? Because particles have more energy. Because particles have more energy now. This is not enough. You have to write one more statement. And you can write either this particles having more energy or above the activation energy. So there will be more energetic collisions or more chances of successful collisions. You can write any one from more particles have energy above the activation energy or more effective collision. Or more chances of successful collisions. Moving to next question. The structure of propene nitrile is shown. This is the structure. One, explain why propene nitrile is unsaturated. It has carbon-carbon double bond. Has carbon-carbon double bond. Number 2, describe a chemical test to show the propene nitrile is unsaturated. It's bromine water. So you write add bromine water. which goes from red to colorless. Now for the color, you can either write other colors like red, brown. They are also accepting red, brown color. You can even write orange for this. D, draw part of the set structure of polypropene nitrile. This is propene nitrile. C double bond C, C triple bond N, H, H, H. So instead of showing this C triple bond N, you can show it as CN. So the polymer must be having single bonds only. This must be the repeat unit. Hydrogen atoms. This must be the polymer. A factory uses 150 tons of propene nitrile to produce polypropene nitrile. The percentage yield is 95%. Calculate the mass of polypropene nitrile produced. So you need to calculate the mass of propene nitrile, polypropene nitrile. They have provided us with the percentage yield, that is 95%. So first of all, what we need? We need the mass of polypropene nitrile. It must be 1750. So you need to calculate the 95% of 1750. Simply 1750 multiplied by 95 divided by 100. So 1750 multiplied by 95 divided by 100. 9,500. 9,500 tons. One minute. There's a mistake here. 1750 into 95 divided by 100. Yes. 1662.5. 1662.5. 1662.5. This will be the mass. 1662.5. B9. Alkenes are a homologous series of unsaturated hydrocarbons. The table shows information about some alkenes. So we have ethene, butene, hexene, decene, 2-decene. The molecular formula, melting point, boiling point is provided. A. Decene is a liquid at 25 degrees centigrade. How can you conclude? How can you make this reduction from the data in the table? It's very easy. It's a liquid. The melting point is below boiling point. This melting point is above melting point. Melting point is below 25. It has a melting point below 25 and boiling point above 25 degrees centigrade. So you write melting point below 25 degrees centigrade, boiling point. That's why it's a liquid at above 25 degree centigrade. Next question. B. Butene boils at -6 degrees centigrade. Use the kinetic particle theory to explain what happens when butene boils. The particles gain energy. So you write particles gain energy. Then they move away from each other. Particles move away from each other. See, a sample of ethene gas is in a gas syringe is heated from 20 degrees centigrade to 100 degrees centigrade. The pressure remains constant. Describe and explain in terms of the kinetic particle theory what happens to the volume of the gas. The volume will definitely increase. So you write volume of gas increases. And particles spread out or move away. Particles move away or spread out. D. At room temperature, ethene diffuses faster than butene. Explain why. We have ethene and butene. Coming back to the table. Here is ethene, is butene. C2H4 and C4H8. If you look at the molecular formula, it straight away indicates that butene is having higher MR than ethene. So you can easily compare their MR. So you can write ethene has a lower relative molecular mass than butene. Part E. Draw the structure showing all the atoms and all the bonds for two isomers with the molecular formula C4H8. C4H8 is butene. This is butene. It's an alkene. So there must be carbon-carbon double bond in it. So you can draw any of these, any two from your 1, 2, 3, 4. I'm placing double bond here. First on the right hand side. 1, 2, 3, 4. These are hydrogen atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. These all are hydrogen atoms. In the next structure, I'm changing the position of double bond. 1, 2, 3, 4. Now I'm placing double bond between the middle carbon atoms. So the last carbon atom on the right hand side, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now this time I am going to change the position of an alkyl group, that's methyl group. So we'll have 1, 2, 3. Now this one for the alkyl group, that's methyl here. Placing the double bond, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You can draw any two of these. These all are isomers with the molecular formula C4H8. F. The structure of hexene is shown. Draw the structure showing all the atoms and all the bonds for the product of the reaction of hexene with steam. You can draw one of these, when you react alkene, this is hexene is alkene with steam, you will get alcohol. So in this case, we will get hexanol. So you can have two possibilities. As you see the double bond here, you can have either OH at this point or at this point. So first of all, I'm going to show all the atoms of carbon 1, 2, 3, 4, 5, 6. Now I'm placing OH on the first carbon atom. Now hydrogen atoms. In the next possibility, I'm going to change the position of OH. First carbon atom 1, 2, 3, 4, 5, 6. Now this time OH is placed on the second carbon atom. This will be the second possibility. Both of these structures are correct. You can draw any one of these. That's all for this video. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.